Okay, on problem 5, we're using properties of limits to find the given limit. And so what we do in a case like this is we take the highest power of x that we see, and especially since nothing factors to cancel out, we are going to divide every term by that power of x. So notice I'm just taking every term and dividing it by x squared. And so what that creates is, on the first term, your x squareds cancel out and you just have a 14. On the second term, your x on top cancels and leaves you with just an x on bottom. And then, of course, you have a 7 over x squared. On the bottom, same thing, x squareds cancel. On the next term, you get a 7 over x. And then on the last term, you have minus 29 over x squared. So there is a property that says anytime we have the higher power of x on bottom, and we're going to allow x to go to infinity, the limits of those terms will actually tend to 0. And so you can think about it like if you had a pizza and you cut it into 10 slices, and then you came back and you cut it into 100, or you divided it by 100, and then you divided it by 1,000. Well, the slice of pizza that you get is getting smaller and smaller and smaller, and so that's why we say those terms approach 0. So my limit in this case ends up being the 14 over 4, but make sure if it reduces, you do reduce that final fraction. So my final answer there is 7 divided by 2. Now, I do want you to show me a table since I am requiring work. Yes, it is a property that, as I mentioned in the previous, if your bigger power of x is on bottom and you're letting x go to infinity, yes, that we do know that limit goes to 0. But in this case, I want you to show me a table. So you're kind of showing me proof of why that is. And I just simply chose values of 1, 10, and 100, plugged them into the original function. So you can see I get, when x is 1, I have the fraction 5 over 8. When x is 10, now all of a sudden we have 5 out of 800. And when x is 100, you've got a teeny tiny fraction of 5 out of 80,000. So that's going to be the way that you show me that that actual limit approaches 0. All right, so then we get into derivatives on the next question. So starting out with just basic power rule, not a lot of work you can show there, but you can kind of show me like I did here, pull the power down to the front so you can multiply. So 9 times the negative 3 gives me the negative 27. And then, of course, you decrease your power by 1. So that's kind of what I'm showing you there. So the new power becomes negative 4. And then same thing on the next term. Pull that power to the front, 8 times negative 1, or that was a negative 8. I think I wrote over it there. So negative 8 times negative 1 gives you positive 8, and then decrease that power by 1 to get the negative 2. So I do realize there's not a lot of work there. On the next one, you're finding a slope and then an equation of a tangent line. Remember that it is your first derivative that actually gives you the slope of an equation of a tangent line. So starting with the function that I've given you here, we first take, using our power rule, and we get a derivative of 4x cubed minus 36x. Now, they did tell me that x is negative 2. I have to know that to find the actual slope at a specific point. So I'm going to plug that value into my derivative function and then just simplify it. And so in this case, I end up and I get a slope that would have a value of 40. Okay. So when we are looking for an equation of a line, you need a slope and you need a point. So the next thing I did is I had to figure out what my y value is when my x is 2. So now I actually went back to this original equation that they gave me here, and I plugged in my negative 2 into the original function so that I could see what the y value is of that point. So I ended up with the y value of 25. So you actually have negative 2 comma 25 is the point on your line. And to find the equation of the line, you now are going to look for the b value. So just using my y equals mx plus b, I plugged in my y value of 25. Here's my slope of 40, my x value of negative 2, and then I'm looking for this b. So it's just an algebraic equation at this point. 25 equals negative 80 plus b, and if you added the 80 to both sides, you end up with your b is 105. So your final equation, when you put it back into the y equal form, y is equal to 40x plus 105. Okay, so with question number 9, we are showing the product rule. So I don't want you to FOIL that out. If it specifically says product rule, I need to see the product rule. So product rule says we take the derivative of this first expression, which is the 4x, and then we multiply it by the entire second expression. Then we add, and now we take the derivative of the second expression, which is the 3, and we multiply it by the entire first expression. And then go ahead and do your distributing and combining like terms. So notice when I distribute my 4x, I get a 12x squared minus 20x. And then when I distribute my 3, I get a 6x squared plus 9. So your x squared terms can be combined. 12x squared plus 6x squared is 18x squared. And then we have minus 20x plus 9. You're not solving anything here, so you're just going to stop. That is your derivative at that particular point. Question 10 asks you to do the quotient rule. So remember, with the quotient rule, you're going to first take the derivative of the expression on top, so that just gives me the 9, multiply it by the bottom, and then in this case you subtract, and then you take the derivative of what's on bottom, which is 5, multiplied by the top. Now, a lot of times people forget that you then have to divide by the bottom squared. So don't forget this part here, because that is part of the quotient rule. Go ahead and simplify the top as much as possible. So we'll distribute the 9, distribute the negative 5. And then notice the 45x and the negative 45x, they actually cancel each other out. 72 plus 10 leaves me with an 82 over 5x plus 8 squared. And we're just stopping there at that particular point with that particular question. And then finally, on this last one, we are doing a chain rule. So remember, with the chain rule, you're still going to, in this case, pull the power to the front. And of course, it's multiplied by the 48 that was already there. You're going to leave everything inside here alone, so that you can subtract 1 from the power. So you've got a 6/5 minus 1. Think of it as 6 over 5 minus 5 over 5. That leaves you with the power of a fifth. And then the chain rule says you have to go back and multiply by the derivative of what's inside here. So don't forget, the derivative of 4t cubed is a 12t squared. Some of y'all forgot to go back and multiply by the derivative of the inside. Simplify it as much as possible. You can get on a calculator at this point. If I multiply 6 times 48 times 12, that's where I'm getting the 3,456. You still have the 5 on bottom. I just pulled the t squared to the front here, and then I have my 4t cubed minus 9 to the 1/5. And again, you're just stopping at that particular point.